Now we'll return to talking about implicit sequences. The first sequence type that we created ourselves was the recursive list. And streams are closely related to recursive lists. But, unlike a recursive list, which must have its entire representation in memory explicitly all the time, streams have aspects that are computed on demand, or lazily. In computer science, something that's computed lazily is something that's only computed when it's needed, as opposed to being computed in advance. And streams have this property. So streams are lazy recursive lists. A stream is a recursive list, but the rest of the list is computed on demand whenever anybody asks for it. So let's just contrast our old rlist implementation with what a stream is. We'll start out by talking about how the constructor works. So an rlist takes anything as its first element, and then as its second element, you pass in the rest of the list. So the second element of the rlist constructor has to be an rlist, or the special singleton value rlist.empty. Streams are quite similar. The first element can be anything. However, the second element is new. It's a zero argument function that returns a stream or stream.empty. So this is extremely similar, except for we use stream instead of an rlist here, except for the fact that the second element is now a function that returns what we want, the rest of the stream, as opposed to the rest of the list itself. Now, other than that, streams and rlists are used interchangeably. They both have first and rest attributes, and the first gives you the first thing in the list, and the rest gives you the rest. However, the difference is that behind the scenes, the rest of the rlist already exists, whereas the rest of a stream is computed when somebody asks for it. Let's, starting with this, take a look at how these two things work. So I'll load in an implementation of an rlist and a stream. The rlist implementation is something that we've seen before, whereas the stream is new, but they behave in similar ways. So I can make an rlist whose first element is 1, second element is 2. I construct it like that, that's the representation, and if I bind it to a name, and I ask for the first thing, or the rest first, I can get the elements out, and s.rest.rest is an empty list. So what about a stream? Well, let's rewrite our list here so that we can see the direct contrast. The only difference is that instead of putting a stream as the second element, I write a function that returns a stream. Now, the repr string for a stream says that the first element is 1, but the second, which is the rest of the stream, has yet to be computed, because we created a function here, but we haven't actually called it. So there's no way for the stream to know that the second element is stream 2 yet, because no one has ever asked for it. So if I bind this to s, and then I ask for s.first, I'll get 1. If I ask for s.rest, I'll get a stream that starts with 2, and might have some more stuff after it. And s.rest.rest is actually the empty stream. So if you construct a stream with just one element, then the second, or the rest of the stream, is assumed to be empty. And I can get the number 2 by looking at s.rest.first. So it behaves just like an rlist, except for stuff is getting computed lazily. How can we see that contrast? Well, here's an rlist where the first element is 1, and the second element is 1 divided by 0. That gives me a 0 division error immediately, because it tries to figure out what the rest of the rlist is, the first element of that, and it finds out that it's tried to divide 1 by 0. By contrast, here's a stream whose first element is 1, and second element is 1 divided by 0. No problems yet. Why is that? It's because the rest of the stream hasn't actually been computed. We created a function that, when called, will raise a zero division error exception. But it hasn't been called yet. It doesn't get called when I look up the first element. It only gets called when I look up the rest. Now we actually try to compute the rest of the list, and we find that the rest of the stream has 1 divided by 0 in it. And we get a division by 0 error. So that's the difference between our list and a stream, is that you need to pass in a function as the second element of the constructor instead of just a stream or an R list itself. So what's the point? Well, we can represent sequences implicitly using streams. We don't need to explicitly store all the contents of the sequential data. Instead, we can just have a function, which one day will compute the rest if anybody is interested. This even lets us compute infinite sequences. So next we'll look at the stream of integers. An integer stream is a stream of consecutive integers, starting with some first integer. So an integer stream starts with the first and is constructed by passing in that first and a function, compute rest, which takes 0 arguments, as the second argument to any stream constructor does. And what compute rest does is it returns an integer stream starting with first plus 1. So the rest of the stream starting 1, 2, 3, 4, 5, 6 is the stream starting at 2, then 3, 4, 5, 6. Here's the code. Define an integer stream starting at first, where by default first is 1. The way we'll compute the rest of this stream is to return integer stream of first plus 1, where this first is returning to this first in an enclosing scope. Okay, now the stream itself is constructed from the first number and then the function that computes the rest if anybody asks for it. So the way this will work is that you'll say that s is an integer stream starting with 3, and you'll find that s.first is 3 and s.rest.first is 4. Cool. Integer stream. Compute rest is a 0 argument function that returns an integer stream starting at first plus 1. Integer stream is a function that returns a stream starting at first, and if anybody asks for it, we'll compute the rest, as I've specified above. Now this code won't run directly because stream is actually a user-defined class. I'll show you the implementation before the end of lecture. But what I first want to show you is what happens when you create an integer stream. So I've done so here. An integer stream is just a function that when I call it, say on 1, I'll create a stream starting with 1. And the first element's 1, the rest of the first element of the rest is 2, and the first element of the rest is 3, etc. So what is this rest of rest? Well, that's a stream that starts with 3, and the rest has yet to be computed yet. Neat. So this can go on forever. Implicitly, there's a sequence of integers that never ends. But the stream is only going to use up memory in the computer for the part of the sequence that we actually care about, which so far is just the 1, the 2, and the 3. We're also going to use a function called firstk, which lets us inspect a stream by just putting the first k elements, in this case k is 10, into a list so that Python prints it out in a nice way. So there's the first 10 and there's the first 20, and it's okay to compute the first 1,000, and that just means we're expanding more and more of the stream.